Hello and welcome to today's webinar, Applied Blockchain 101. Before we get started, I'd like to go over just a few administrative details. As you have noticed upon joining the webinar, everyone has been placed on mute for the presentation. At the end of the presentation, there will be a Q&A session. In your GoToMeeting control panel, you will see a questions box. Please type your questions or comments into the field and hit enter. Please note that the recording of this webinar, along with the slide deck, will be posted to the WEDI website, and downloading instructions will be emailed to all registrants. Without any further ado, I'd like to go ahead and hand it over to today's speaker. Peter?
Thank you very much, Sam, and welcome to everyone on the call. I'm going to talk about applied blockchain today, give a quick intro, motivation, talking about the growing need for trusted data, and you will see that blockchain is not just used for cryptocurrencies, but increasingly for enterprise applications. I'm going to focus on that and explain the differences. How applied blockchain works, a small primer for those of you who haven't been able to catch up on the latest developments and also may have some general questions about blockchain itself. And then again, with a focus on applied blockchain, not the academic version. Then key benefits, use case areas, challenges. Throughout the presentation, I'm going to focus on healthcare, always binding it back to latest trends and best practices and insights. Then go into key benefits, challenges as well that blockchain has right now, and solutions thereof. And then go into a deep dive use case on the DCSA front with compliant saleable returns. Finally, I'm going to talk about what's next, and that's pretty exciting in terms of I was asked to talk about interoperable exchange of data, and that's exactly here the point that I'm going to share with you and show you the latest trends there. And then, as Sam said, we'll finish with questions and answers, and we'll have 15 minutes for that. So please, if you have any questions, as Sam said, please type them so that we can go over them later. Thank you. So without further ado, I'm Peter Ebert. I'm with CryptoWork. Just for sake of a very brief context and intro, who is CryptoWork? We're a startup company in Silicon Valley with an office now in Munich as well. We founded in 2016. Behind the technology is a professor for blockchain and one of our co-founders at UC Berkeley here in California. We focus on anti-fraud solutions, but increasingly also on data exchange, secure data exchange. And our vision is a future where trust is built into every product, process, and transaction. So everything is data-driven now. And for some industries, not everything is data-driven now, and then we need to talk about interoperability, but everything starts being data-driven. But there is, whenever you think about data-driven environments, you need to be able to trust the data, because if you can't trust the data, then you face existential risk. And I'm going to talk about this with a focus on healthcare in particular. Because what we see around us in our personal lives, but increasingly also on the enterprise front, and we open the newspaper and we look on the internet and we see data manipulation, data fake, and increasingly hacking that is going on. And in a data-driven world, it's particularly paramount to make sure, as I said earlier, to be able to trust the data that your company is ingesting, the data that your company is running on, processes, regulatory compliance documents, and what have you. If you can't trust the data, then again, we have a big problem as an industry. And as data manipulation, not just data hacking, but increasingly also data manipulation is the new normal, we as a society, I would say, need a solution. And blockchain is one of these solutions. So if you look at this in terms of fraud, and fraud is everywhere, as you know, in traditional processes, but increasingly on the data front, you see some of these numbers here that are really scary. And don't want to go into all the numbers, and many of them you may know already, suffice to say that this is not sustainable. So let's look at one example, very recent example here in July 2018, where you see that fake data is entering China or has entered China's vaccine system. And this is not a specific problem with China or anything. It's just one recent example. What can happen if fake data enters our systems, our supply chains, and our backend systems. Another example that is very much close to home, is, as you can see here, for clinical research associates hiring, there were more than 7,000 identified fake CRAs in North America. So if you are thinking about hiring such a role into somebody in that role, you should know about these things. So it's not just supply chain related, it goes into the very fabric of our society, as I said, and our business. Another example here is the hacking that took down a New York hospital for 6 weeks. And it's one of these examples that you may know about, that you may have been affected even by, and it's by no means a single occurrence. It just gives us a flavor for what that means in the future if somebody can get into our systems, but then also wreak havoc on processes, and to the point where we can't use medical devices, we can't keep a hospital up and running. And that's, again, it's very scary. Sometimes, and most of the times actually, you wouldn't even know that this is happening until it gets to a point where it's life-threatening. Some of these examples here, just to mention a couple, is also the cost related to these breaches, because ultimately we are, as businesses, we are liable in many cases for the results. And so you see some of these examples here. Also, it's not just the hackers that are coming through the internet. Sometimes it's just negligence by employees or disgruntled employees that would compromise a system, that would lose systems, that would, here in this case, just kind of forget about updating software, and for that reason, suddenly patient data is on the internet, visibly to everyone that has access. So these are very scary examples, I think, in the healthcare business, and it's by no means only the healthcare business that has these cases. So what can we do? And you see this quote here that really relates not just to the monetary cost, but also the brand cost, that this can affect the company's reputation to the point where you see shares drop, and we see this everywhere. So the good news, and after all this doom and gloom, the good news is there's an antidote, and it's to infuse blockchainified trust into everything that is data-driven, so into your systems, into the systems of your trading partners. And that's the stance and the topic of what I wanted to talk about in terms of applied blockchain, to illustrate what the antidote looks like, how you can actually implement these antidotes now. For that, I wanted to talk a little bit about how blockchain works, because as I said, blockchainified trust, what is that? How does it relate to blockchain, and how can blockchain help with trust? And you'll see a little bit of the inner workings, core principles of why a blockchain is called a blockchain and how it works. Again, this is highly simplified. And then I'm also going to talk about the difference between cryptocurrencies, because many of you, as I said earlier, may have heard a lot of hype around ICOs, Bitcoin and others, and going to try and explain the differences and to bind them back to business. So when you think about blockchains, Yeah, the major difference here is, and you see the left-hand side, there is a block X. Let's start with this. So picture a block as being something where you can store data for a specific amount of time, and that's called heartbeat for a limited time, and that's different for different blockchains, but in general, so maybe 14 seconds for Ethereum and 10 minutes for Bitcoin blockchain. Other blockchains have seconds, and so just picture a bucket where data transactions can be put in, but they can't just be put in like a typical database. If you have write access to this database, you could just put in data. Here you have what is called a consensus mechanism. It's like a gatekeeper. And that gatekeeper can be very complex, very energy consuming, like in Bitcoin blockchain's case, or it can be very simplified. And then there is a trade-off between security and speed and energy usage. But there's, whenever it comes to blockchain, there is or should be a consensus mechanism here that decides who can write to this particular block during this time. And then when this block, the time is over, the block is sealed, closed, so nobody can write into anymore. And then it's attached to all the previous blocks that you see on the right-hand side. And then everything is encrypted and distributed to each partner on this blockchain. And so that's why it's called distributed ledger. So typically you have a number of different nodes, how they're also called in technical terms, partners, that each hold a copy of this blockchain. And the moment the new block comes in, they get a copy of this block and attach it to their copy. And so in the case, for example, on the public blockchain side, Ethereum, there is 20,000 plus partners that every 14 seconds get a block like that. And the magic here that comes in, and the major difference is now it's a read-only, you could say data base. So everything that's in these blocks now cannot be modified anymore. And that's where you hear the word immutable. And it means essentially that since there's many parties who have a copy of that, a hacker would need to essentially hack into each copy and then also go back in time and hack that. And that's pretty much virtually impossible to do for a well-designed blockchain. And that's the core of the benefit of a blockchain. You get something that cannot be forged, that cannot be hacked, and everyone that has access to this block can look into it. So let's talk a little bit about what is the difference between cryptocurrencies and blockchain in general. And you see down the public blockchain, hybrid blockchain, and private blockchain types. So there's different types, and with some of these examples that I mentioned, Ethereum, for example, is a public blockchain. Public blockchain means that you can download and become a node in this Ethereum blockchain now. And the moment you are on, you essentially get copies of all the blocks that are coming in and can also put transactions into blocks. And there's a bidding involved, and I don't want to go into too much detail here. A private blockchain on the other side, on the right-hand side, for example, IBM Hyperledger, Quorum, others are, as the name says, private, so you can just download a copy and get access. It's a private set of partners that agree on using this particular blockchain. And so it's also called permissioned, meaning everyone that's on there knows who everyone else is and trusts each one that is on this blockchain. So a very different world. It's a little bit like intranet versus internet. So has a number of advantages, but also disadvantages. I'm going to touch on them in a moment. And then in the middle, you see hybrid blockchains, essentially trying to combine the best of two worlds. For example, Zinfin in this case is using Ethereum public blockchain in a private setting combined with Quorum. Now on the top, you see things like Ether and Bitcoin and cryptocurrency. So the blockchain stands for automated trust. And remember, you heard me talk about blockchainified trust. That's the layer, that's the infrastructure that actually makes this possible to automate trust. And cryptocurrencies are applications on top of blockchain. So for example, in the case of Bitcoin, it uses the Bitcoin blockchain, but it's not the blockchain, it's just an application on top. And you can imagine if you have virtual money, that the most important thing with money is that you can't just copy and paste it. And so that's where blockchain comes in. Now, what does it mean for healthcare? And how can this be applied in the spirit of applying blockchain? Now, any application, any process that wants to automate trust should be able to do this and will be able to do this with blockchain. And so it's just another area, and I say just like cryptocurrencies, but it's a very much broader business field, and you can imagine a lot of applications in your realm and that are of interest to you can actually use the trust aspect, the blockchainified trust aspect of blockchain, just as cryptocurrencies can. And I'm not going to talk about cryptocurrencies from now on. I'm going to talk about only these apps that are in view for applying blockchain in an enterprise-grade fashion. So what is the big difference? And we get this question a lot as one of the key questions. My systems are safe. That's some of the IT managers we're talking about plain out say, well, why do we need blockchain? I don't trust that it's better, more trustworthy. And this graph helps a lot in these discussions to illustrate the major differences. And it revolves around any traditional system that has an admin control, so access of an admin, means it can be hacked ultimately, because if that admin is either disgruntled or the password is phished or whatever it is, if you get access to the system, there is a single point of control and you can manipulate data, you can delete data, you can edit data. And you heard me talk about this earlier, that this increasingly happens, and our traditional systems obviously aren't safe enough, else these guys wouldn't be able to do so much damage right now. So I touched on no data changes. That's also different. As I said, in a traditional system, you absolutely can change data. And even if there is a write-only state, if you have an admin account, the admin can overwrite that. Many independent copies, that's another aspect that a typical traditional system doesn't have, in combination with everything that I just mentioned. So another reason why somebody can't just come in and hack something or change something, because there's these independent copies somewhere else, and it's virtually unhackable that way in the combination. Now, what can you do with blockchain? Where do we see, and where does the industry see the major benefits and key use case areas? Traceability is one of them. You can imagine if you have a supply chain, track and trace also it's called, and you'll see a use case in a moment, where various parties, manufacturers, wholesalers, logistics, down to hospitals and pharmacies, need to transact with each other along a blockchain, along a supply chain, and there is counterfeits coming in. And how do you make sure that you can actually trust the party that you got your product from, that it wasn't switched, for example, or that there was another channel of product coming in, a great channel? So that's one. Transparency is another one. If you have a blockchain that allows you to share data in a sense that it's making that information transparent to others, while making sure that there is no fake data that is injected here in the process, is another one. Efficiency, collaboration. Efficiency is actually coming in, and I'm going down here. Efficiency is reached, for example, by minimizing the time it takes. So think about a credit card transaction, and it takes time. and there is typically process steps in there and cost involved, and you can actually, if you can trust the data that is based on the blockchain trust, you don't need these middlemen, you don't need these latencies, and you don't need the related cost. So efficiency is increased and cost is lowered. Collaboration, another piece, and I actually wanted to land on auditability because that is also a major piece of discussion in healthcare. How can I lower my cost of compliance? How can I make sure that sensitive documents stay the way they are not being tampered with? And I can actually trust if somebody shows me a certificate, somebody shows off for credentials. If I hire somebody, we just saw the press example, how much fraud happens there. And I can trust that I lower my cost, and I also, from an auditability point of view, I can prove that I hire people that have the qualification to work in a specific area, have the training. I can document that I performed all the checks and balances and so on. Now, when it comes to blockchain, there is, traditionally speaking, limitations. And so it all is a wonderful concept. And if you look into the under the hood for a moment, in a business sense, there are key challenges that the industry grapples with. And that is scalability. So for example, if you have a public blockchain like Bitcoin, right now, Bitcoin blockchain cannot do more than 5 transactions per second worldwide. So that's not much, and it doesn't work for any serious enterprise use case. Ethereum can probably do a little bit more, but not more than 10 right now. And then there's cost. If you have a public blockchain, people have to pay for the transactions, and there's a bidding process that can go all the way up to $60 per transaction. That's completely not viable for enterprise applications. If you have a private blockchain, on the other hand, you have other problems. And one of them, interoperability, that actually is not just private blockchain, but in general, when we are going to talk about this in more detail, which blockchain? So it's like which ERP system, and why would your industry partner settle on the same system so that you can transact? Which blockchain type, public, hybrid, private? Let's say you start with a private blockchain, but then suddenly you realize, oh, wait a minute, there is new M&As and trading partners that are on a different blockchain. How do you make sure that the data is actually interoperable and all the applications don't need to be re-implemented? And finally, excuse me here, the data privacy piece, which is a major reason for private blockchains. If you have sensitive data, you put it on chain, as we call it, so on the blockchain, everyone on this blockchain can see it. And in a private setting, that's maybe okay, but in a public blockchain, you can imagine you don't want to have 20,000 different parties that you may not even know look at your data. So these are the key blockchain limitations. And then when you look at, a typical applied enterprise grade solution, and this is true for blockchain solutions as well as for any other enterprise solution that is mission critical, you have these various attributes that you want to have fulfilled. Interoperability is on top. It has to be secure, but it also has to be scalable. So 10 transactions per second, that doesn't work. It has to be cyber resilient. We talked about fake and hacking. So that means cyber resilient means that it's not just able to keep hackers out, which you probably can't, maybe in combination with other technologies, but it can be resilient in the sense that you can recover. And some of these scenarios are very hard to recover from without blockchain, if you can recover. You also want to have something that is future-proof, so that, as I mentioned, and interoperability is part of this equation, is that if you have system upgrades, if you have an M&As, if you have additional scenarios, you don't want to have 10 different blockchains at some point on different versions with different partners. So something that is actually future-proof and it's easy to implement. And then, and this is a personal opinion, our opinion is the more secure, the better, and the public blockchains, public proof is, in our point of view, the highest security at this point. Think of notary public versus the more trustworthy something is in terms of certification or blockchainification in this case, the more secure it is. So we think public proof is the highest security. So the good news again is there is a solution, and I don't want to pitch here or go into too much technical detail, and I still included this because I think it's fair to you to not just have fluffy words, but really show that there is a solution out there that can actually interoperably connect any application with any blockchain. And the way this works is by not putting data, sensitive data or any readable data on chain. And you can imagine, if you remember what I just showed with the blocks, if you have a lot of data and a lot of partners that are putting data in these blocks every couple of seconds, you can very easily see that at some point the whole thing will blow up. It doesn't work that way. And so we don't suggest putting data on chain. Our stance is to leave it off chain, but use blockchain only in the sense that you drive trust with it. And there is a very cool mechanism for this. It's called hashes or digital fingerprints, where let's say you have a contract for a moment. So you're transacting with a supplier and you have a contract, and you want to make sure that this contract hasn't been tampered with and isn't going to be tampered with, and you can prove for regulatory purposes that this contract was in place at a specific time. And if there is a dispute later, you want to be able to mathematically prove that this document hasn't been tampered with and you have the original. And so the way this works in this concept is that you don't put the contract on chain, which would mean that everyone on this blockchain would see your contract, which you don't want. It would mean that at some point, if everyone puts all their data on there, it would blow up, and so on and so on. No, you only digitally fingerprint this document, and that's an open source approach throughout the industry, used throughout the industry. And you only put the digital fingerprints, which are very small, about 32 bytes long. If that's, I hope it's not too much technology. So very small file. And that one you can actually put on blockchains, any blockchain, and there you have interoperability. You never shared the original data. The data stays where it is. It is flowing in the process that you set up with your ERP system in your universe, and still later on, you can actually pull out the digital fingerprint, let's say 2 years later. And since it was put in that blockchain, one or more actually, you can prove if the fingerprint still fits this file that it hasn't been tampered with. And with the transaction record of these blockchains, you can prove when you put it there. And so mission accomplished without sharing sensitive data, works with any blockchain, and you can independently prove the proof of existence. So let me give you this a use case, a really tangible use case, and that is tamper-proof track and trace, as I mentioned. And you may be familiar with the DCSA regulation that is now in effect in the US. It, in a nutshell, says that every prescription drug has to be uniquely identifiable, has to have a unique ID on it, not pallet level, but each item, billions of them, as you can imagine. You'll see the dates. Last November, it went into effect in the first phase, and in 2019, you see it goes into further effect, this law. So the industry is under this regulation, and you may have comparable regulations in your area. And so when we started talking with, in this case, Merck and SAP about showing how blockchain can solve here, Merck told us that they would love to see a solution. And of specific pain was the so-called saleable return scenario. They said, if you can solve that, we really are interested in our dream partner in crime. In this case is AmerisourceBergen on the wholesaler side. And so they are making about $2 to $3 billion every year by repackaging returned prescription drugs that are still not expired, that are still good to be repackaged, and so on. With this new DCSA law, they can't do it unless they can prove irrefutably that they are not repackaging and reselling counterfeits. And the problem here is that they can't prove this because they don't have the original data. In this case, that would be AmerisourceBergen, who wants to repackage, but they would need to go back to Merck because only Merck knows whether that Merck product that they just that was just returned, by the way, to the tune of 60,000 per day, hitting their distribution return centers. For each of these items, they would need to go back according to DCSA law and make sure and prove and then document to the regulator that they actually asked and got the green light from Merck before they repackaged. So a perfect scenario, and as I said, it's a high value scenario, 2 to 3 billion. Now, I talked about simple implementation. I talked about interoperability. I talked about leaving the data where it is. I talked about you don't want to re-implement the wheel. These are very complex systems. They are in action, they are mission critical, they are running, and you can't just stop them. And I also talked about the good news that there is solutions for that. So let me show you how, in this case, we work with Merck and AmerisourceBergen, and how you could do similar things in your environment, where we actually were asked by Merck, can you put the data can you use, first of all, they said, can you use Ethereum as a public blockchain? Remember, because they wanted to have this high security there, and they also were very aware of the scalability issues right now. And so they wanted to test in this POC, not only does it work, but does it work with a public blockchain, and does it work with ultimately with all trading partners? And in this case, both of the companies here that we worked with are SAP customers, not exclusively, but in this case, they both use what is called SAP Advanced Track and Trace, and they were already linked. And this is, I'm not saying this is SAP specific, this is one example that is very typical in the industry, where you have major ERP vendors or software vendors that are implemented in various combinations and in trading environments. And so you have to be able to work not just with this ERP system, but then also use the benefits if there is a common ground that you lower cost by being able to use it. In this case, all the data exchange was already set up. What was missing was essentially the blockchainified trust. And so in this case, we did a test with 100,000 prescription drug serial numbers. Each of them had 3 events to it, package shipped and scanned. And then each event, as I said earlier, the data stays in the system, but we were asked to hash and put the hashes into Ethereum and in parallel into Hyperledger, which is a private blockchain. So to also show redundancy and also show that this works independent of type of blockchain. So we took these 300,000 hashes, we in this case got from SAP. As I said, the data was already flowing. For implementation sakes, Merck only needed to nod and say, yes, you can hash SAP this data and give it to the hashes to CryptoWork, to put it into Ethereum. That was the implementation part. And so we put this into Ethereum and Hyperledger. And then on the backend side, AmerisourceBergen got a repurposed SAP tracking app. Let me show that to you here, which is able to, a part of SAP Advanced Track and Trace, which was able to and is able to scan these Merck items in this case for the POC sake. But in this case, it didn't go back asking the SAP Advanced Track and Trace system whether this item was a counterfeit or not. It looked right into the blockchains and of use. And so you see the results here, so split-second results. And again, it's not just saying, yes, it's okay, it's green, it's not a counterfeit, but each of the events was hashed and put into the blockchain so you could trust the packed, shipped, scanned. And even the scan of this, in this case with this app, was again hashed, and then the hash was put back into the blockchain so for AmerisourceBergen to prove that they have performed the scan and what was the result of the scan. This also was hashed and put in the blockchain. So in the end, that was showing how you can phase in, very simply in this case, a blockchainified trust solution which satisfies DCSA law by 2019, by 2017 even, and going forward, extended DCSA even to 2023. So there are very, very elegant solutions the moment you know how this can be done, and you can do it with your technology. Some of that translated, as you can see here by Forbes, in billions of future savings. And the result thereof was also when Merck and AmerisourceBergen saw this and the industry started to becoming aware of these solutions. And tell our story a little bit here, we were invited to talk about interoperability by the non-profit Public Center for Supply Chain Studies that is sponsored by the top 50 pharma companies here in the US. And so what we did there, and this goes into the next step and what's next, and where is the trend going on top of, let's say, the blockchainified trust aspect itself, became very apparent that a major challenge in the industry was to actually share data in a trusted way with very, very interesting and very, very strict requirements, and sometimes even well, almost oxymoron-like requirements. So for example, I want to share data with AmerisourceBergen, but my competitor is not allowed to see that data. But AmerisourceBergen is also transacting with my competitor, obviously, and they want to share data with AmerisourceBergen too, but they don't want me to see that data. And so there is a lot of requirements in this case that are really hard to satisfy. And what you're looking at here is our proposal that we presented then to the Center for Supply Chain Studies in a first instance. And we are now in the position to be able to run POCs with this because it's real. And the way this works, and really simplified again, but it's building on the blockchainified trust in addition to now also applying this for sharing data. And we call that CryptoWork Cloud or Crypto Cloud as a project name. And the way this works is you have your existing system and it provides data to trading partners, regulators, and what have you. That happens now. You may have this data on a file share. You may already have APIs, application programming interfaces set up for that. But this is happening, and increasingly there is digital transformation where additional data needs to be shared. Now, how can you, without stopping the system, without re-implementing the data, without sharing the data, the sensitive data, keeping the sensitive data behind your firewall, and then using blockchain in an interoperable way, so you don't want to be locked into a specific vendor or a specific blockchain technology that may become obsolete tomorrow. And then what? You want to share this data, and the way this works is, as I mentioned earlier, you can fingerprint the data, and you only share the fingerprints, and it can be, then the data can be via an application API, application programming interface, simply connected to your existing existing system landscape. And so you put these fingerprints, and in addition, not just these fingerprints, for example, a log file. So for example, if you have a file that you want to share with a trading partner, like a TI, a transaction information file, that one, you, in addition to keeping it for yourself, it's actually encrypted automatically the moment you transfer it into this cloud. It's blockchainified, so the event that you shared it, that the file was put on this cloud, when it was put there, all these events are automatically blockchainified in more than two, ideally more than one or at least two blockchains of the choice of that in who is running this cloud. And then the data itself, as it is encrypted, it cannot be read, not by the host, not by the cloud. It's just, it's, for this particularly, we call this also crypto bucket. For this particular file, it's on the cloud and only you have the key, the decryption key. And then you can, with a trade partner of your choice, give them that key selectively. You can remove this file anytime from this cloud, so it becomes invisible. GDPR is one of the examples in Europe, regulation that you have to be able to forget data. With a blockchain, traditionally you can't do this, as you know from my explanations earlier. It's write only. In this case, there's an encrypted something there that nobody can read, so you can actually remove it from the cloud, and then on the blockchain itself is only the fingerprint, and again, it's completely anonymous. And so what you get with this is essentially the best of all worlds. You keep your system running, you have a simple implementation, you can fulfill the regulatory compliance, you can embrace the new blockchain world, and it's very simple to implement. And that's where we see the world going in the next step in health, but also other industries. You can see clinical trials, medical records, prescriptions, legal records, certifications, classified documents, and the list goes on and on. As I said, whatever data that works for any data asset, you can imagine can be shared with this and blockchainified with this. For us specifically, the next Lighthouse project, I mentioned DCSA, focus on US, is the next step, where we bring in both aspects. One is the blockchainification itself. So if you only want to use that part, it's also possible. Or and in addition, the new crypto cloud approach. Then blockchainified e-prescriptions in Europe. In Europe, there are some countries that are still on a paper-based process for prescriptions. And there's a lot of discussions there and regulatory compliance requirements coming in there as well. And this is a solution, and you'll see us solve some of that. I can't go into details, unfortunately, here for many of these projects at this time, but just know that this is going on in the background, and there's a lot of interest coming from Europe regarding this. And then also cold chain, and this is, I know some of you have cold chain scenarios where temperature is of issue. So it's not just where an item was and who had it under custody, and has it been recalled or not, and is it still a valid item, or has it been was there a counterfeit injected into the supply chain, but also what temperature was that item at? For vaccines, for example, that's a major issue, but also for other items. So that is another big area for us where crypto cloud and then blockchainification of all the events is in view. And that brings me to questions and answers, Sam.
Great, thank you, Peter. Well, the first question that I received was asking if the presentation will be available to everybody, and yes, I will be emailing out the presentation along with the link to the recorded webinar for everyone. If you have any other questions, please feel free to type them into your GoToMeeting control panel. And if you have any questions following the live webinar, feel free to email me, sholvey@weedy.org, and I will pass them along to Peter to get you some more information. But I'm not seeing, oh, we just got a question, sorry. Who/how do you know what is stored in the blockchain?
That depends on the blockchain itself. And there is, if you have a public blockchain, like as I said, Ethereum, for example, whatever is visible in terms of data. So if it's not encrypted, the data is visible to every node, every partner on that particular blockchain. And so if you encrypt the data on the other side, it depends on the size of the data. So I think the question relates to visibility. So in any blockchain, and that's a core requirement, even and a use case for blockchains, is sharing data is in view, and so it's visible the moment you open it up. There are some new technology, or not new, but there are some technologies that, particularly on the private blockchain side, create things like channels. So you do have a private blockchain, but you even want to compartmentalize more who has access and who can see what's on the specific blockchain. And so there's all kinds of technology solutions by various blockchain vendors. And as typical in technology, there's pros and cons. More than 1,500 different technologies right now, and that's also a reason why we believe that's really important to have something that works for everyone, like it's interoperable, because who knows what's next, and how do you make sure that your trading partner settles on the same technology then that you're requiring.
Great. Next question. Could you please recap the CryptoWork Cloud concept? Crypto Cloud stores the encrypted document, but the owning organization would need to interact with multiple ledgers in order to establish the encryption fingerprint. Did I understand that correctly?
Wow, it's let me kind of bring up the slide again here and try to answer your question. And please feel free to chime in again if I didn't correctly understand your question. So the process is, yes, you are sharing encrypted data, and each data piece that you're sharing, we call it again is crypto buckets, has its own key that you hold as the author of this crypto bucket. And then this crypto bucket is put on this crypto cloud, and only you hold the key. And then you can share the key via other methods with your trading partners, which then enables them, if they also have access to the crypto cloud, then to download that bucket, crypto bucket, and decrypt that bucket with your key that you got from somewhere else, not through the crypto cloud, because else the crypto cloud would be able to essentially see the data. To make it a little bit more technical to understand for those of you who are technical, what you can do is attach non-encrypted metadata to this bucket, meaning you can actually query for specific things like a serial item, serial number on the crypto cloud, which would then enable others to see that there is maybe 10, maybe 20, maybe 100 different buckets relating to this item, this serial number. They still wouldn't know who owns this item. They still couldn't access the bucket itself, but they would then need to ask. So the crypto cloud could then say, oh, we have 100 buckets and here are 10 owners. Each one has contributed here. And you can ask these owners for their keys to their respective buckets, and which would then enable you to download them if you get them, and still keep everyone else in control of their data at any point in time. Does it make it a little bit clearer or more clear?
Well, we've got some more questions rolling
Okay.
in. He responded, yes, thanks. Do you see this technology being used in the sharing of genomic data? Are there such applications on the horizon?
Absolutely. So this is today we're focusing on healthcare, but there is a lot of interest in other industries as well. And the cool thing, and now I'm biased obviously, but the cool thing is this works generically, as you say. So it works with any digital asset because any digital asset can be hashed or digitally fingerprinted. You can, since you don't store data on cloud, on chain, you don't run into these scalability issues. So again, let's say you have something very big, this cloud can deal with it. So you are using technology that is designed to scale, to store large amounts of data versus putting all this data in a blockchain. So from a scalability issue, that works as well. And then if you can open this up, this cloud, you can run it privately inside of your organization at first. So if you are an organization that is operating, let's say, in 50 different countries, and you have 2 M&As every year, which is very typical, then you can see the benefits right off the hand, even without thinking about trading partners. But then if you go broader, you can use the same mechanism for any other data with your trading partners, and even mixed model where some of the crypto buckets you keep to yourselves, you just don't share them outside, but they still live in the same area with all the various benefits attached to them, and others you share, and others you have rules even on where you can say, well, after 6 months or after 6 years, I want to delete them automatically because then I'm not required anymore to keep them. So there's a number of benefits with this. And yes, it works for generically for data in general.
Great. One more question. Is it possible to provide temporary keys for certain data on the cloud, or would the underlying key need to be modified to lock out any owners that one would want to restrict access to later?
Yeah, and this is in the first instance, what we envision is that the key is fixed. The key can apply to different it's your key, so you can select which key you apply, but we would suggest at this point in time to not make it temporary unless so if you have a crypto bucket that should expire, for example, you can have it removed, or you can attach a rule that removes it. But typically, for simplification, think about one crypto bucket has a key, and the moment you don't need this bucket anymore, you can have the bucket removed, and that also removes essentially the key. And then you can upload a new bucket, or you can think about a rule.
Thank you very much, Peter. This presentation was very, very informative, lots of great comments, and thank you to all of our attendees for participating. And again, if you have any other questions or need further information, please don't hesitate to email me, and I will be emailing everybody the presentation slide deck as well as the link to the recorded webinar. So thank you very much for joining us today, and I hope everybody has a great weekend.
Thank you so much. Same to you, Sam. Have a wonderful week, everyone.